Welcome back to Math Video Tutorials, and thank you for tuning in. In this tutorial we're going to take a look at these identities. In the first part of this tutorial we're going to see how we can prove these identities. In the second part of this tutorial we're going to practice on them and use them to prove other identities. Okay, so we're going to attempt to prove the two identities. We'll start with this one here. For each identity, we need to use the Pythagorean identity, the popular one you are familiar with. Sine squared plus cos squared is identical to 1. Now, for this one here, because we have the tan, right, so we need to divide by cos squared. Let's write it down fully. Plus cos squared, this one here, divided by cos squared. And that is 1 over cos squared. We know that sine over cos is the tan function. So therefore, sine squared over cos squared will be tan squared. And cos squared divided by itself, of course, is going to be 1. Therefore, 1 over cos we know is sec. So therefore, 1 over cos squared will be, of course, sec squared. And that's how you prove the identity. You could do the same thing for this identity using the Pythagorean identity. So give it a go if you want to. Pause the video and play it later to check if you got stuck somewhere in the working out. For me, I'm going to continue. So for this one, because we have cot, so I need to divide everything by sine squared. Sine squared x divided by sine squared x plus cos squared x divided by sine squared x. That is equal to 1 over sine squared x. Again, sine squared divided by itself will give us 1. Cos divided by sine is the equivalent of cot. So therefore, cos squared over sine squared is equal to cot squared. 1 over sine is cos sec, so therefore 1 over sine squared will be cos sec squared, same as this one here. So we have proven the identities now. So now let's see how we can use them to manipulate other identities. Okay, let's practice on reciprocal identities. We got this exercise asking us to use the identity sine squared plus cos squared to prove this identity. So we need to start from here somehow and to arrive to this one. We're gonna divide by sine squared because I have cos sec there and I have cot. All right, just to remind ourselves, cos sec theta is 1 over sine theta. And for the cot, cos theta over sine, because I have cot and I have cos sec, they both have a denominator sine theta. So I need to divide by sine squared, right? Because everything is squared, all right? Can you see that? So we're going to divide by sine squared. Let me first copy down this identity. So we're going to say we divide by sine squared. That's the first step. And then I'm going to write down all the working out. So cos squared theta over sine squared theta is equal or identical over 1 over sine squared theta. So we have divided by sine squared. Now what do we need to do? We need to simplify. For example, this one here will give us 1. This one is cos over sine. Cos over sine is cot, and because this is squared, we need to have cot squared theta. And 1 over sine is cos sec. So therefore, 1 over sine squared is going to be cos sec squared. cosec squared theta. All I have to do now is just subtract cot squared from both sides. Cot squared theta and we minus cot squared theta here. I will get 1 equal or identical cosec squared theta minus cot squared theta. It looks exactly the same, it's just that the sides are the wrong way around. So let's switch them around. We say cosec squared theta minus cot squared theta is identical to 1. And that's how you prove it. This one shouldn't be difficult to prove because we know the sec squared identity is 1 plus tan squared, and the cosec squared x is identical to 1 plus cot squared x. By minusing the 2, I'll get sine squared minus cosec squared. And on the other side, the 1 will be eliminated, and we will be left with tan squared x minus cot squared x as required. Alright, we've got another one to prove. Cosec x minus sine x identical to cosec x over sec squared x. We're going to start from the left hand side and hopefully we arrive to the right hand side. I think that is the best way forward with this one here. We'll see. So on the left hand side, well, I've got cosec. I'm going to write it down using the regular trig function, which is 1 over sine minus sine x, and that would be equal to, of course, changing to the common denominator, sine x. So I'll have 1 minus sine squared x over sine x, because this is over 1, of course, so you times it by sine x to get the denominator, common denominator sine x. So you times this one by sine x, you get sine squared x. All right. Now we know the identity, Pythagorean identity. 1 minus sine squared is cos squared over sine x. This one is, you don't need to prove it at this stage. You just use it. Cos squared x plus sine squared x identical to 1. That's the one I used. So therefore cos squared x is equal 1 minus sine squared x. This numerator here is this one here. I changed it for cos squared x. Now what do we do from here? I can rewrite it as cos squared x times 1 over sine x. The reason I'm doing this because I spotted the 1 over sine is cosec, right? So I can write it down as cos squared x times cosec x. So we got the numerator, and now we need to sort out the denominator. Well, we know that sec x is 1 over cos x. So basically, if I make cos the subject, cos x, it will be 1 over sec x, alright? And then if I elevate to the power of 2, both sides, I will get cos squared x equal 1 over sec squared x. And that will be replacing this one here. Okay, so we're going to take this, replace it with its equivalent. So 1 over sec squared x times cosec x. Now at this stage you got a fraction times a trig term or function. You can put them together as one fraction like this one here. So because 1 times cosec is going to be cosec x over sec squared x, and that's the answer, proven as required.